रिकॉर्डिंग। ठीक है।
आने वाले को
हाँ, स्टार्ट हो गया।
हो रहा है।
हाँ, इसमें तो दिखा रहा है स्टार्ट रिकॉर्डिंग, अभी स्टॉप रिकॉर्डिंग आ रहा है।
स्टॉप मत करना।
ठीक है। इसमें ओबीएस में से तो कहीं माइक वाइक नहीं बंद करना होता ना?
नहीं करना पड़ेगा, तो बस उसको ऑन करके जो मीटिंग है उसमें आ जा।
ठीक है। ठीक है। ओके। ठीक है। स्टॉप रिकॉर्डिंग का वो आ रहा है। ठीक है। ठीक है। हाँ, ठीक है, कोई बात नहीं। हम्म।
Okay, so good afternoon, everyone. I am Devarun Banerjee. I'm going to take this live interaction session on this particular NPTEL topic, technologies for clean and renewable energy production. It's our last live session, number 8. So what we do in this particular live sessions is that get a brief overview of the last week lectures, and then it's followed by some sample uh, assignment problems. So in this week, the first lecture comprised of the basics of biomass and wastes as a source of energy, the different conversion routes where by the routes this biomass and wastes converted to give us energy, and anaerobic digestion of biomass and wastes. So if we see the first lecture, the basics of biomass and wastes and source of energy, where basically the lignocellulosic agricultural residues are discussed as a source material, which primarily contains the cellulose, hemicellulose, lignin as a constituents, majorly as an average. mm, about 38 to 50% of cellulose is the composition. Hemicellulose about 23 to 32%. Lignin is about 15 to 25%. In different types of biomass and wastes are also discussed. Different routes for energy production from wastes. Among that, thermochemical, biological, chemical, and physical conversion are there. Then the anaerobic digestion of biomass and wastes, where we can see that the different types of feedstock, it's kind of can be the different types of feedstock can be taken in the anaerobic digester. Among that, energy crops, animal waste, industrial waste, MSW, restaurant food industry waste, sludge from wastewater treatment plant. All this can be used as important feedstocks. So basically, this kind of flexibility or this uh, greater variability of the feedstocks is important for anaerobic digestion, and as a result, different kinds of products such as biogas, hydrogen, biofertilizer, compost, reusable water, these kind of products are obtained. Different steps of the anaerobic digestion is discussed, and then the quantitative description of the overall biomass degradation, and then important thing is that the elementary description of the anaerobic digestion, which means that a hydrocarbon biomass is nothing but a hydrocarbon, and then it undergoes a kind of a hydrolysis, which gives us methane, CO2, and some other hydrocarbons in the form of C5H7 O2N, which is a basically empirical formula of bacterial dry mass. and then the ammonium ion, the bicarbonate ion, this kind of ions are obtained. So using this kind of formula, we can actually get if we know the original empirical formula of the wastes, then we can get how much quantity of the CO2, methane, and all this bacterial dry mass can be obtained by the anaerobic digestion. Okay, then different kinds of bacteria are actually used for this kind of biological methods. Uh, in the method, the routes comprise of hydrolysis, fermentation. So different kinds of hydrolyzing and fermenting bacteria are there, and via process such as acetogenesis, acidogenesis, the hydrolysis product are actually converted uh, into different products like sugar, fatty acids, alcohols, CO2 and fatty acids, amino acids, ammonia sulfide, CO2, H2 into fatty acids, glycerol in acetate and CO2. Now, different types of acetogenic bacteria, methanogenic bacteria, these all act together one by one in this to successfully carry out this entire process of anaerobic digestion. And different types of group 1, group 2, group 3 kinds of methanogenic bacteria are there. Detailed different more or less the biologies are actually uh, discussed over here. Okay. The overall flow sheet of the anaerobic digestion of waste is important. Initially, the shredding, blending, this kind of pre-treatment is actually happens. So shredding, blending, pH adjustment, and overall some further pre-treatment is occurred. And then um, the main part is the anaerobic digestion via the mesophilic or thermophilic kind of bacteria. Then whatever mixed gas is obtained as a product, this is separated, and whatever effluent in the liquid form is obtained, then that is also again kind of recycled and also dewatered to disposal to treatment according to the requirements. Then there are dry and wet type of anaerobic digestion, where in the dry type of anaerobic digestion about 25 to 45% total solid content in there, whereas in the wet is much lesser. The reactor volume in dry type is actually lower, where wet is greater. So this kind of comparison is also discussed. You have to study that. The basics of this methanogenic bacteria, where the methane is actually formed. Methane having a important constituent of the natural gas, so having a good calorific value. That is why the production of methane is also very important. Okay, and then further kinetics are actually discussed, and different types of anaerobic digester, low rate, high rate digester are also uh, discussed. Okay, and then the operation of the digester. So the most digesters operate in the temperature range of 30 to 38 degrees Celsius to optimize time. The digester gas produced from the process may be used for the heating purposes. Optimum pH range is about 7 to 7.2, and it's maintained by properly seeding fresh added sludge and not excessively withdrawing the sludge. Then the two-stage digester two-stage digester is can in the two-stage digester the anaerobic digestion is actually can be carried out. So basically in a single phase digester the optimum pH is 7. The acidogenic reactions favor at the pH range of 5.5 to 5.9, whereas the for methanogenic reactions the pH requirement is much greater. Then the second lecture comprised of some basically other routes of the biomass waste transformation, like in the chemical route. Uh, the chemical route comprises of transesterification, the organic wastes for transesterification, oil seeds to biooil production, need for the biooil upgradation, biodiesel production from biooil through transesterification, flow sheet for biodiesel production from various feedstock, and then comparison between biodiesel and different biooils. So basics of the transesterification reaction. What is that? It is basically with the help of an alcohol, the plant oil is actually converted to the fatty acid, basically ester and glycerol. So that during the process of transesterification, an alcohol reacts with the triglyceride oils contained in the plant oils, animal fats or recycled greases to form fatty acid alkyl esters and glycerol. The reaction requires heat and a strong base catalyst such as sodium hydroxide or potassium hydroxide. Okay, so basically the for transesterification, the organic wastes can be used uh, where via this kind of different routes, the bio oil can be produced, and further via different upgradation techniques, the bio oil can be converted into biodiesel. Okay, so the major processes for the bio oil production from oil seeds. It comprises of conventional and advanced methods. The conventional methods follows expeller press method and solvent extraction method, whereas the advanced methods comprise of ultrasonic assisted extraction and supercritical fluid extraction method. Then different types of the systems for the bio-oil extraction, such as the oil press and solvent extraction techniques. Via picture, it's actually shown here. Can go and search in Google and YouTube and then try to understand what these processes are all about. Different types of factors which affect the oil extraction, and then the comparison between different types of lipid extraction processes such as oil press, solvent extraction, supercritical fluid extraction, ultrasonic extraction. This kind of overall comparative study is actually shown here based on its advantages and disadvantages. Okay, where you can see the oil press having an advantage of its simplicity without the requirement of any solvent, whereas the large feedstock in the, or the biomass requirement and the slow process and low reaction rate are the disadvantages. Whereas the solvent extraction process is actually uh, disadvantageous because the solvent recovery technique is actually expensive, and a large amount of solvent is required, and also the solvent is expensive. Whereas the latest techniques actually use the supercritical fluid extraction or the ultrasonic assisted extraction, where the simplicity or the less time, less solvent requirement are the major advantages. However, these are in the range of some research research lab scale researches, and its scaling up is actually quite difficult, and that is why further an extensive study and researches are going on. Then different types of common fatty acids are overviewed over here. It comprises of the saturated and unsaturated fatty acids. Then the most important thing is that the why it needs to be upgraded. The plant oil, because the plant oil is actually much more viscous than conventional diesel fuel. It is 11 to 17 times thicker. Therefore, for the transportation purposes, if we need to use it as a transportation fuel, as in the automobile sector or energy production, it would be very difficult because of the high pumping cost and everything. Okay. Further problems, what will be happening? You can see that if the fuel is too thick, it will not atomize properly. When the fuel injectors spray spray it into the combustion chamber, and it will not combust properly. So the injectors may get coked up and leading to the poor performance, higher exhaust emissions, reduced engine life, everything. So a generalized flow sheet for biodiesel production from various feedstocks is shown here, from the bio oil, further transesterification reaction, and then via separation between biodiesel and glycerol, and get the refined biodiesel. Different steps for the upgradation technique comprises of the acid esterification, then the glycerolysis, enzymatic method. This kind of all techniques are there, and then the transesterification, the major step, and then the uh, you can see the factors affecting the transesterification process performance. And the different types of heterogeneous catalysts are actually used, where strontium oxide, K2CO3, TiO2, the amber list 15, sulfonated carbon based catalysts. These are the all different types of catalysts are actually uh, examined by different researchers, and a very high up to about 90-92% yield are actually obtained under different operating conditions. Further steps: methanol recovery, biodiesel refining, glycerol refining. These are the some additional steps after the biodiesel production shown here. And then different types of like the feedstock if you use, uh, then what kind of biodiesel can be obtained. Like if we use babas oil, we use soybean oil. uh, this kind of the comparison is shown based on the properties. Then the third lecture basically contains about the physical conversion of biomass and wastes for energy use, which comprises of the densification of biomass and waste. Okay, so the densification is nothing but the process of increasing the density of something. So it makes a fuel denser and gives more uniform properties with respect to its raw form. So different steps are in the densification process. The fundamentals, it tells about the basics of the densification of biomass, and what it results in, it results in the mechanical interlocking and increased additional cohesion. Okay, so they get binding. So by this binding, the uh, uh, whatever biomass or waste is there, its density is increased. Okay, so when the material is compacted with low to moderate pressure, then the space between the particles is reduced. Uh, but the pressure is increased at certain stage particular to each material. The cell walls of the cellulose constituent are collapsed. Then they get merged with each other. So to get a very high density, the pressure required for this compression is also very high. Or the pressure required is about more than 100 megapascal. So to overcome the very high pressure requirement, different types of high viscous bonding media like binders are used, like molasses, tar, or maybe other some compounds are actually used. Okay, and what is the resulting product? The resulting product is termed as a pellet briquettes. So the different types of briquetting, it depends on the compaction, the range of the compaction. Based on that, high pressure, medium pressure, low pressure is actually divided in these different types. And after that, the importance of the briquetting process, which is a very high and medium pressure operation. High and medium pressure compaction normally does not use any additional binder. Okay, so for the low pressure, when you want to operate it at low pressure, then we need to an additional binding agent. Further process like piston process, using a piston, using a screw extruder, this particular technique can be undergone. Okay, and different comparison between different densification processes are shown here. What kind of output, what kind of energy consumption, the particle size, these all based on this, they are basically shown. Now, whatever product we are actually getting, so the combustion performance of such product in the terms of briquettes. And then the utilization of the briquette is important. So via a carbonization process it can be used. So what is a carbonization? Carbonization is a partial pyrolysis process where up to 600 degree Celsius in the under inert atmosphere, uh, the whatever our briquette or pellet is, it is actually heated, and CO, CH4, H2 formaldehyde, methanol, this kind of things, gases are can be released. And via this carbonization, the properties can actually be enhanced. The fixed carbon rate can be enhanced, whereas the volatile matter moisture content, they actually can be decreased. You can see that char is obtained after the carbonization, where the fixed carbon content is increased from 15 to 69%, whereas the volatile matter content is decreased from 70 to 17%. The briquette characteristics are also important. So the handling characteristics, the fuel characteristics are also important. So by the process, by which process the briquetting is carried out is important, and how the basically the feedstock is. Then different types of briquetting machine, like the manual machine, maybe the automatic machine. These kind of techniques are there. After that, the last lecture comprised of the energy conservation and the different practices, the energy conservation, basics of the energy conservation for the efficient use of energy, some energy conservation areas in the industrial level, in the household level, in the community level. These are actually mm, overall discussed. How basically energy conservation can be carried out, which you need to go through. Okay, so coming to the sample assignment questions. The first question is, dash is a biological conversion route for energy production from waste. Briquetting of biomass, fermentation, liquefaction, none of the above. So the correct answer is the fermentation. You can see the different routes for the energy production from waste comprises of thermochemical conversion, biological conversion, chemical conversion, and physical conversion. So the thermochemical comprises of combustion, gasification, pyrolysis, liquefaction, these processes. The biological combustion comprises of enzymatic process, fermentation process, anaerobic digestion, like that. Other processes: hydrolysis, solvent extraction, transesterification are part of chemical conversion, and mechanical extraction, briquetting of biomass, distillation. So the next question is the cellulose content is higher in feedstock biomass, then dash would be the rate limiting step. Fill in the blanks. Acidogenesis, acetogenesis, methanogenesis, or hydrolysis. So hydrolysis is the correct answer. So the steps of anaerobic digestion comprises of hydrolysis, acidogenesis, acetogenesis, methanogenesis. So normally the methanogenesis is the least limiting step, but if the cellulose content is higher in the feedstock, then hydrolysis may be the rate limiting step. And the presence of lignin is what controls the rate of hydrolysis. So lignin and cellulose, these are kind of trade-offs. Obviously, if lignin is higher, the rate of the hydrolysis will be lower. So the next question is the rate limiting step for the methane formation or high rate digestion is acidogenesis, acetogenesis, methanogenesis, hydrolysis. I've already told that the general rate limiting step. The next question is the anaerobic digester operating in a mesophilic temperature range is made of concrete and steel, iron and sand, copper and sand, or none of the above. Yeah. So concrete and steel is the correct answer. So most digesters are actually heated and these actually operate in the mesophilic range. So usually they are made of concrete and steel. Which of the following is an unsaturated fatty acid? Oleic acid, myristic acid, stearic acid, or palmitic acid? So the correct answer is the oleic acid. You can see the saturated fatty acids are such as lauric acid, myristic acid, palmitic acid, stearic acid. Whereas the unsaturated fatty acids are such that oleic acid, linoleic acid, or arachidonic acid. Okay? So oleic acid is the correct answer. So the correct sequence of steps involved in the production of methyl ester from plant oil. There are different options. You have to give me the right answer. So the correct answer is the acid esterification followed by the trans esterification, methanol recovery, biodiesel refining, and then glycerol refining. Okay, so the acid esterification, trans esterification, methanol recovery, biodiesel refining, and glycerol refining. Then the factors affecting the trans esterification reaction are free fatty acid, water content, alcohol to oil mole ratio, or all of the above. So the correct answer is the all of the above. Okay, because the reaction temperature, reaction time, alcohol to oil ratio, catalyst concentration, free fatty acid content, all these affect the trans esterification process performance. Then, which of the following is the correct sequence of steps involved in the densification of biomass? Compaction, compression, concretion, concentration, where the other options are also there. The correct answer is compaction, compression, concretion, and concentration. Okay, these are the correct sequence of steps involved in the densification. And poor power factor results in heat damage to insulation and another circuit component, reduction in the amount of available useful power, required an increase in conductor and equipment size, all of the above. So the correct answer is all of the above. Okay. So the poor power factor can actually result in heat damage to insulation and other circuit component, reduction in the amount of available useful power, or required an increase in conductor and equipment size. So all of the above are correct answer. So basically, what is the power factor? It is nothing but an ratio of true power and apparent power. So it's an expression of energy efficiency, and it's basically the ratio I told between the true power and apparent power. Which of the following municipal refuse components has the highest moisture content? Leaves, rags, cotton, linen, gas, or garbage? Yeah. So garbage is the correct answer. You can see garbage having a 75% of moisture content, whereas grass or leaves having about less than that. Uh, the rags, cotton, linen having the very low, about 10% of the moisture. Then which of the following municipal refuse components has the highest heating value? Wood crates, boxes, scraps, garbage, bush branches, paper cardboard bags. So the correct answer is wood crates, boxes, and scraps having the highest heating value. You can see about 18.20 megajoule per kg. Which of the following process is not a process of biological conversion of biomass to energy? Microbial fuel cell, fermentation, transesterification, anaerobic digestion. The correct answer is transesterification, because transesterification is a chemical conversion. With the help of alcohol, the plant vegetable oil is converted to the biodiesel and glycerol. So it's a chemical process, not a biological process. The other all are fermentation, anaerobic digestion, microbial fuel cell, all are biological processes. The correct statement regarding the kinetics of methane production is the presence of lignin decreases the rate of hydrolysis. Transfer of the gaseous products to the gas phase cannot be rate limiting step. Presence of lignin increases the rate of hydrolysis, or if cellulose content is lower in feedstock, hydrolysis may be rate limiting step. Yeah. So presence of lignin decreases the rate of hydrolysis. Already told earlier. So dash and dash precludes the growth of methanogenic bacteria and thus reduces the methane production. Low pH and high retention time, high pH and short retention time, high pH and high retention time, or low pH and short retention time. The correct answer is low pH and short retention time. Okay. So in the flow sheet, generalized flow sheet for biodiesel production from various feedstocks, you have to identify the X and Y. The options are given over here in the bottom: methanol and recycled greases, methanol and vegetable oils, vegetable oil and recycled greases, vegetable oil and methanol. The correct answer are vegetable oil and recycled greases. Okay, these are the correct answer. The second last question is, which of the following saturated fatty acids has the highest melting point? Linoleic, linolenic, stearic, or arachidonic? So the stearic acid is the correct answer. Okay, you can see the chart of the melting point. Among the saturated fatty acids, stearic acid is having a very high, about almost 70 degrees Celsius of melting point. The last question is, in biodiesel refining, biodiesel once separated from the glycerin goes through a series of cleaning up or purification steps to remove which of the following compounds: excess alcohol, residual catalyst, excess acid, both A and B. The correct answer is both A and B. So once separated from the glycerin, the biodiesel goes through a series of cleaning or the purification steps to remove the excess alcohol, residual catalyst, soap, everything. Okay, the purest form of the biodiesel we can obtain in this way. So both A and B, which says about the excess alcohol and residual catalyst, are the correct answer. Okay, so that is all from my side. Thank you for joining the class.